So here the question is two similar thin equi-convex lenses of focal length of each is f are kept coaxially in contact with each other such that the focal length of the combination is capital F1. When the space between the two lenses is filled with glycerin which has the same refractive index as that of the glass, then the equivalent focal length is capital F2. What would be the ratio between the combination without glycerin F1 divided by the combination with the glycerin F2? This is the ratio we are going to evaluate now.
First, we can draw the picture for the given question. Two similar thin equi-convex lenses. It is kept in the air. Suppose this is a thin plano-convex. This is another thin plano-convex lens. The medium is here. So suppose if you are taking the focal length of the first one, it is given. So you can take this is f. This is also because it's a similar convex lens. This is also f. The combination of these two focal length it is given. It is f1 for the system. So it is kept in here. It is coaxially, it is identical. That's why the focal length of the two lenses are f. They are equal. Now we want to find the what is the resultant focal length, that f1. This is a combination of the two thin equi-convex lenses focal length f1, that we need to find what is the f1 for. We know the relation from the two lenses. If it is attaching with each other, the 1 by f1 is equal to the resultant focal length should be equal to the 1 by this focal length of the first length convex lens, the 1 by focal length of the second convex lens. So 1 by f plus 1 by f, because these two lenses are identical. So 1 by f1, that would be equal to, the denominators are equal, you can keep as it is. Numerator it will become 1 plus 1, 2 by f, or you can say the f1, the resultant convex lens. If you are inverting left hand side, you got to invert the right hand side, f divided by 2. So this is our first combination. You can take this equation number 1. The second one, it is given when the space between the two convex lens is filled with the glycerin, then the equivalent focal length is f2. So we need to draw for this one also. Suppose again we are taking the same thin equi-convex lenses. This focal length is f. Then we are coaxially put the another lens. It is also the focal length is identical lens. The focal length is ef. Now in between these two lenses it's filled with the glycerin. Suppose this spaces is filled with glycerin. That means this glycerin will act as a its convex lens. It will act as a thin thin eco is thin convex lens. So concave lens, sorry, this is convex lens, this is thin convex lens. So this glycerin will act as a concave lens. So you can call this focal length is minus f, because it will also looking like identical. The space in between, it will be glycerin. So that will be this glycerin having the same refractive index as that of the this lenses glass, because lenses are made up of glass. So if this refractive index 3, actually here the refractive index of the first lens is equal to refractive index of the second lens, then this refractive index equal to the glycerin. So that means we are keeping in this second diagram one convex lens, one concave lens, another concave lens, three lenses together. That means the medium is here, it's a homogeneously uniformly filled medium. That means it's homogeneous medium. So now what is the resultant focal length? We need to find the resultant focal length. You can call that is f2. It is given in the question. So the name is f2. What you have to do, we need to find the f2. For that we have the relation, again the same result relation. The resultant focal length 1 divided by f2, that would be equal to the first convex length focal length in reciprocal, that is plus f, Next is concave lens. The glycerin will act as a concave lens. That focal length is 1 divided by minus f, or else we can write minus 1 by f, plus the last convex lens focal length is 1 by f. Hence 1 by f2, that would be equal to, you can cancel plus 1 by f minus 1 by f, so it is 1 by f, or f2 you can call it's f. So this you have to take on the equation number 2. This equation number 1 represents the resultant focal length of the combination of two convex lens, that is f by 2. The second focal length is f2 represents the resultant focal length of the combination of three lenses, two convex, one concave lens. The glycerin is acting as a concave lens. Now what they are asking, the ratio between f1 divided by f2. So the ratio f1 by f2, that would be equal to f by 2, that is f1, f2 is f, you can cancel this f, it will be equal to 1 by 2, or you can call this is 1 is to 2. This would be the right answer.
So from the above discussion, we got the option that would be equal to the second option, 1 is to 2. This would be the right answer.